Today we will be answering exercise A from chapter 17 of the Giancoli textbook. So the first step we do is read the problem. So the problem is asking us, suppose a proton m equals 1.67 times 10 to the negative 27 kilograms was accelerated from rest by a potential difference VBA equals negative 5,000 volts. What would be the proton's change in potential energy and final speed? Our second step is identifying the what. So what do we know? And what are we trying to find? Well, we know that VBA equals negative 5,000 volts. We also know that the mass of a proton is equal to m equals 1.67 times 10 to the negative 27 kilograms. Now we can start on step 3, which is figuring out the equation to use. So we know that the change in potential energy can be calculated by change in potential energy equals Q times VBA. So if we look at our equation sheet, we can see that Q is equal to negative E, and that negative E is equal to negative 1.6 times 10 to the negative 19 coulombs. We can now add these values into the equation change in potential equals Q times VBA. After plugging these numbers into my calculator, I am given an answer that tells me the change in potential energy is equal to negative 8 times 10 to the negative 16. However, we also want to find the final speed. So the equation for the final speed, as given to us in our equation sheet, is V equals square root of negative 2 times Q VBA divided by m. So now we can fill in the numbers. Once we have our final equation written out with all numbers involved, we can plug this into the calculator and get a result of V equals 9.8 times 10 to the 5th meters per second. Well, let's clean this up a little bit. So we'll rewrite it at the bottom of the page as change in potential energy equals negative 8 times 10 to the negative 16, and V equals 9.8 times 10 to the 5th meters per second. And that, my friends, is our final answer.